Right, hello everyone. Happy Friday. Let me shuffle a few more things around here and stop some of the previews, and then we will dive on the road. Well, I don't think they got roads in the ocean, right? One of the nice things about the ocean. A few nice things. I'm not big on the ocean. I'm scared of the ocean. Anyway, this is neither here nor there. Okay, there we are. Hello everyone. My name is Tim, and I go by Foamy Guy on GitHub and Discord. This is the Deep Dive program. If you are new to this program, what we will be looking at primarily is stuff related to CircuitPython. This is the website for that project, circuitpython.org. You can head there to learn more if you have never heard of that before or don't know what it is. The high-level version, though, is that this is basically an implementation of Python that runs on tiny computers called microcontrollers. This is a microcontroller. There's a US quarter for size, so this is a pretty small little device, but it essentially has a whole computer in there. This one even has a screen on it and battery charging, so it has a couple extra capabilities. But the idea is that we have an implementation of Python. It's running on this device, and we can just save our Python code to this device, pretty much just like it was a thumb drive, and then it will execute our Python code for us. It can interact with the hardware peripherals that are connected to the microcontroller. So it can interact with the screen. It can interact with all of these I/O pins along the sides here. It can interact with the battery, or it can be powered from the battery, I should say. You can plug in sensors or RGB lights or buzzers, beepers, buttons, pretty much any kind of like electronical input or sensor or widget. You can connect up with these microcontrollers, and then you use Python code to control it. So that's kind of the high-level idea of what we are working on is CircuitPython related stuff. Again, circuitpython.org. This is the website where you can learn more. And then I must say thank you to Adafruit. CircuitPython is an open source project, but Adafruit is the company that's paying the folks who work on CircuitPython, right? There's a team of folks who work on the project full time. There's a couple folks like me who work on the project part time. And Adafruit pays us to work on the project, to update libraries, to make new libraries, to write guides, to help foster the community around it, to run the meetings. All of these kinds of things. Adafruit is the company that is paying for that. So huge thanks to them. And if you would like to help support that open source CircuitPython project, one of the ways you can do that is by purchasing hardware from Adafruit. They have all kinds of microcontroller devices, much like this one here, which is an Adafruit device. This is a Feather ESP32S2 TFT. Has quite a long name, but that's the ESP32S2 TFT. This has quickly become kind of like my go-to device for just randomly grabbing to test stuff out because the Feather form factor is nice. There are lots of Feather wings which can plug into Feathers, although in this one I don't have the pins on it, so we wouldn't be able to do that. But lots of things are made to work with Feathers. It has a stemma cable, so you can plug in any kind of stemma breakouts. And this one has a decently sized screen. It's not a huge screen like a PyPortal or anything like that, but it's a big enough screen to be able to draw some stuff on and test some stuff out. So that's what this device is. You can buy one of those over at Adafruit if you like, if they're in stock. I didn't actually check the stock, so maybe they're not, and I apologize if not. Aside from the microcontrollers, they also have the sensors, the lights, the RGB lights, the buttons, the beepers, the buzzers, pretty much any kind of thing, again, that you can think of that you can hook up to those microcontrollers. Adafruit has got lots of that kind of stuff that you can purchase. So thank you to folks that make purchases from Adafruit again, because they are the ones primarily supporting the CircuitPython project financially. I want to say also, let's see here. How's it going, Paul SK? Happy Friday from Lisbon. Nice. All Pauls represented and accounted for, as well as Radomir's. Nice. How's it going, folks? How's it going in the YouTube over there? Evil Dave of Canada, and then Noridine. Unfortunately, I can't read this last message, but thanks for tuning in nonetheless. Let's see. Oh, Paul Cutler. I think I got a early hug report for Paul Cutler. Thank you, Paul. During the what was it, show and tell, excuse me, Wednesday night programs like show and tell, Paul mentioned that DigiKey has PicoWs in stock, which I missed the PicoW the first time around. So thank you, Paul, for mentioning that, and I jumped right on that Wednesday night, and I actually got a visit from the DigiKey Fairy today with my PicoWs in there. So we'll get those out. We'll play with those at some point, maybe not on this stream, but thank you to Paul Cutler, because I would not have one yet if it were not for you. And if anybody else is interested, DigiKey is the place to be right now. 4,800 of those things still in stock. So if you don't have a PicoW yet and you're looking to pick one up, you got some time, but maybe not much, because this was over 6,000 just 2 days ago. So, you know, they are going still fairly quick. But head there if you want to get one of those. And like I said, we will play with that on a future stream. I'm excited to try out Jeff's build for that PicoW to start testing the Wi-Fi stuff, like with requests and things like that. I think that is that has a lot of promise for kind of like small IoT projects and stuff. So I'm excited to try that out. But in this stream in particular, we're not going to get into there, or we may, I guess, if there's time. But the truth is, the first thing I want to look into is display I/O related stuff. So if folks that have watched before probably know that I spend a fair amount of time in display I/O land. I like to play with you know, the libraries and things that allow us to draw on these screens. And so that is what I'm going to be getting into first, is a particular bug that I've noticed. I'll say relating to display I/O. I don't know if it's you know, I don't know where the bug is at. I know what the symptoms are. The symptoms are that BitmapLabels don't draw on Blinka display I/O. And so we're going to try to figure that out. We're going to put on our investigator hat today. We're going to try to figure out why do BitmapLabels not display on Blinka display I/O. And then if we can, we're going to hopefully try to figure out a way to fix it, which will, with any luck, come shortly after figuring out why it's doing that. How's it going, Beata and DJ Devin? So that's where I'm at, and just to set the stage here, let's go to display text, and I'll show you what is not working right now, and then we'll start digging in, try to figure out what's wrong with it. So simple test, we can just take simple test for, so I'll start with label. So for folks that don't know, display text, Adafruit CircuitPython display text, this is the main library for making text with display I/O. And there are two main classes, two main types of labels. One of them is just called label. That one was the first one to exist. So this one says from Adafruit display text import label, just label by itself. This is the original display text label. And then there is a newer one, which is called BitmapLabel, which has different behavior internally, but it's intended to have the same API, the same programming interface. So they are more or less meant to be interchangeable, but the bitmap one, it essentially stores the entire string inside a single bitmap, whereas the original one, the plain label, as it were, this one stores its string in a series of bitmaps, one for each glyph. So that's kind of the main difference. There's a good guide page actually with a illustration of this. Let me pull that up real fast. Types of labels. This page explains the different types of labels and shows a diagram that kind of lays out the difference between the two. So this is the original, you know, plain label. There is a tile grid and a bitmap for each glyph, and then there is a group which holds all of those tile grids. This one is the bitmap label. There is a single bitmap which holds all the glyphs together, a single tile grid, and that is inside a group still in the bitmap label. So these are the two main kinds of labels, and what we are running up against is that this one, which is the one that I tend to default to use, just because the way that it stores this stuff here is a little bit more efficient. It tends to take a little bit less RAM, especially if you have long strings. And so I tend to default to this one these days, but what I have noticed is that this one does not work on Blinka Display IO. I'll talk a little bit more about what Blinka Display IO is as we dive in, but to start with, I just want to get the basics running and just like verify the issue on the latest versions of the libraries and all that stuff. Like maybe there's some chance that I just had an out-of-date version or something. Maybe it's not actually broken. So that's the first thing we're going to do is just like make sure that what I think is broken is actually broken on the latest versions of everything. And so to illustrate that, I'm going to run this, which is the plain label simple test. This one is not the bitmap label one. This one is the plain label one. Let's see, which side do we want to do? Maybe that one on that side. Is that covered up? Am I covering that up? Not too bad. Maybe if we out there a little bit. Okay. And it's a little small. I guess we could zoom in there. You know, we're not going to be printing anything important there, so it doesn't matter if you can't read this, but it just says hello world because that's what's in the label. And then the bitmap label also has a simple test, which is pretty much almost the exact same code. The only difference is what it imports, because again, the programming interface is intended to be the same so that they are interchangeable. So really all you need to do is import the other one and then use that as the one you create. And we still have hello world. So we just ran both of them on our CircuitPython device, and both of them worked the same. We got a little white hello world somewhere near the top left corner, and both of those did the exact same thing, which is perfect. That's what we want to happen. And if I switch back here, I'll let you see while it's live here. So we'll save, and this will rerun. And now we're looking at the regular label. We can switch back, and now we're looking at the bitmap label. So in CircuitPython land, on the microcontroller, everything is groovy. They both work the exact same. They're both showing their text, all as well. But in Blinka Display IO land, so for folks that might be newer, or if you just don't know, Blinka Display IO, well, let's start with Blinka, I guess. Blinka is the CircuitPython compatibility layer. Let's go Blinka, let's just go Blinka Adafruit maybe. Adafruit GitHub. Just there, right? Yeah. Well, nope, not quite, but we'll want that one too. Blinka GitHub. There it is. So Adafruit Blinka is a project which is a CircuitPython compatibility layer for Raspberry Pi and other single board computers. The idea is that you can install this library on your Raspberry Pi or your similar types of Linux single board computers. And when you have this library installed, it will make it so that you can run code which was originally written for CircuitPython to run on the microcontroller. Of course, a full PC like a Raspberry Pi is a much different kind of environment than a microcontroller. And so, by default, CircuitPython code will not just run on a Raspberry Pi, but this compatibility layer makes it so that it will. So that's what this is about. It's about allowing you to run, CircuitPython code on your Raspberry Pi or your single board Linux computer. One more library, Adafruit Blinka Display IO. This library works in conjunction with Blinka, so it is just another add-on for that compatibility layer, and this one is specifically for the Display IO module. So this one allows you to run, again, on a Raspberry Pi or a single board computer, and this one allows you to use Display IO specific CircuitPython code and run it on that Raspberry Pi with an attached screen, like a SPI or a I2C display. And so I have a Raspberry Pi here, quite a dusty screen as you can see. There's nothing currently on the display, but this display is connected to the Raspberry Pi via SPI. Some of these pins down here are the SPI connection. And so this display is hooked up via SPI, and with Blinka Display IO, we are able to draw things on this display. So I already have a terminal over here. So I'm going to run, let's go cat simple test. Does this one use label or bitmap label? Regular label. Okay, so let's run simple test. So I already have Blinka Display IO set up. We will probably reinstall it, like make sure we have the latest version of everything. We'll do that here in a minute. But let's run this one first real quick. Simple test. There it is. So now this is going to run, and so this is what the simple test looks like, or I think I actually modified it. It's usually pink and green. Mine's now blue and purple because I was messing around with something. But the important bit is that it has hello world written right here. This hello world is inside of a label pretty much the exact same way as our simple test was just a minute ago. We create a label, we just put some text in it, we add it to the group, and therefore it gets shown on the display. So this one is currently using the normal layer, the label, the standard label. But this one, bitmap label. Whoops, I wanted a cat, not ls. There we go, cat. So this one is using bitmap label. If we try to run it, Python 3 il bitmap. Interesting. Ah, okay. I must have started troubleshooting this a bit because it looks like I set a background color. Like I was messing with some stuff. Interesting. Okay, instead of running that one, actually, let's go back to the first one. Let me open this actually. Nope, that's not what we call. Would have taken forever. Oh, okay, it did actually get me closer though, which is nice. New window. Let me change this up a bit. This one I've already done some other kind of stuff inside. Let's get a, let's pare it down back to the actual simple test. Make a file called troubleshoot, bitmap label troubleshoot. I'm going to leave all the display set up, but then I'm going to get rid of all of everything else. So this will set up the display. It will create a group, and it will show the group on the display. So we should now be able to add whatever we want into this group and then show it on the display. I'm going to change this to main group. I like main group better than splash personally. We can take this, we can do that, and then the only difference is we don't want to use board.display. We just want to use, actually we don't even need this. We can just go main group dot append text area. And then we're going to want to do the import. Oh, we already have the import actually, okay. Okay, so this one did not draw anything, but if we switch this over to regular label and rerun it, then it will draw something. That's the theory, at least. Oops. Okay, it's pretty small, but up in the corner there, there's a white hello world. Pretty much the same thing we saw on the microcontroller. Hi, so Blinka Display IO is for SPI and I2C display. Is there another option for using the HDMI Why, yes, there is. There is another option. We'll get into that here in a bit as well. There is a sneak peek if you want to look ahead. There is a thing I created called Blinka Display IO Pygame Display. This project right here, this is intended to work with Blinka Display IO, and it also works with the third-party unrelated project called Pygame. And what this does is it allows you to initialize this Pygame display like this, and then you're going to be able to call like display.show the same way that you would on a built-in display. And this is going to run on a PC. So this is made more to run on a PC or a Linux computer. I believe it does work on a Raspberry Pi. I'm not 100% sure. I haven't done a whole lot of GUI work on the Pi itself, like through its desktop, through its HDMI. To the best of my knowledge, though, as long as you can run Pygame on the Raspberry Pi, which I believe you can, then I think you should be able to use this to essentially create display I/O programs that will go through the HDMI rather than a SPI or an I2C bus. And we will be using this here in a few minutes. Mostly what I wanted to do was on the Raspberry Pi verify that the thing I thought was wrong is actually wrong, and then I'm probably going to switch back to my PC just because it's more convenient to run over there. And so when I run on my PC, I'll be using that Pygame display so that we can iterate more quickly and just try stuff out and see if we can figure out what's wrong with it. But as we can see here, I'll make this bigger. We should be able to just do a big scale or something, right? Maybe even like we could go bigger if we put a new line here. Since it's on a Pi, does that mean Blinka can interface with PIL? PIL plus CircuitPython sounds nice. So Blinka Display IO does use PIL for some stuff. So you could interface your CircuitPython code essentially with PIL. Obviously, you would not be able to run that code on a microcontroller because there is no like CircuitPython version of PIL. But if you're on a Raspberry Pi or a Linux PC, if you're using Blinka Display IO, then you're actually already using PIL to some extent. It uses PIL image objects to basically contain the image that will be drawn on the screen. I believe. It's been a little while since I looked inside Blinka Display IO, but I'm pretty sure that's the way it works. And so you could you could do other stuff with PIL as well. Okay, so that's much bigger, much easier to see. It is still working, and if we switch back to BitmapLabel and we try it one more time, then what we're going to see is that it's not working anymore. Yeah, so it takes it a second to refresh there, but now we have no text. Interestingly, background color. So we're drawing our box, we're just not drawing our glyphs. Okay. So it's not that BitmapLabel just doesn't get shown at all, it is that the glyphs are not getting shown inside of it for some reason. Could be the cost for that. Does that mean Pygamer microcontroller game emulator for the PC someday? I would not say that it's impossible, but I don't know that it's a thing that like I'd be able to make. If you mean like full-on emulator, like you could run CircuitPython code on that emulated device and then see the output of it, I think that's probably further off into the future. The thing that is closest to that right now is Wakwi. The thing I know of, I should say. That maybe there's something closer that I'm not aware of, but Wakwi is a microcontroller simulator and it has access for CircuitPython on a couple devices, I think. I don't remember exactly how to get to the CircuitPython part of it, though. There's MicroPython. Oops. I swear there's a CircuitPython one in here somewhere. What if we say walkwe circuit Python? There we go. Okay. This is a web application. It just runs in the browser, and it simulates microcontrollers, including the Raspberry Pi Pico and a couple others. This project was made primarily more, I think, for the Arduino side of things, but it did eventually come to support MicroPython, and it does now support CircuitPython for the Raspberry Pi Pico. So you can run your code on here. This is the furthest along emulator or simulator that I'm aware of. But I believe the only chip they have is the Raspberry Pi Pico. So if this project ever implemented the SAMD51 as an emulatable chip, then I think the PyGamer could exist inside of there. And then potentially a layer could be built for display I/O as well. I don't know if or when that will actually happen, but I think those are probably the things that would that would probably be the closest opportunity we have to like a PyGamer simulator. Okay, so the main thing I want to do real quick is just double check that we're using the latest version of Blinka Display I/O. How do you, does the status tell you your branch? Adafruit main. Already up to date. Okay. So, Blinka Display I/O is up to date. Display text. Presume is installed from pip, probably. Thought we were years away from web workflow, yet here we are. That's true. Yeah, web workflow did come kind of quick once it was the thing at the forefront for sure. Okay. Where's the, I guess it doesn't have the pip install here. Maybe over here. Do I need an upgrade? I think I might need an upgrade, right? Because I already have it, probably. Already satisfied. I don't think I downloaded anything. I think it's like this, right? Upgrade. Or 1.4. You know though, right? It doesn't, did it? Requirement already up to date? 2.22.11. Okay, so that's the latest version. Okay. What is up with that? Is it like Um, Maybe we should set the color, foreground color. I mean, it should be white by default. Okay, doesn't change when we change the color. We still have the same thing. So latest version Blinka display.io, latest version display text, and we're not getting anything. So now we are going to jump to the PC instead of the Raspberry Pi. I just wanted to verify on the Pi that it was actually the case that it wasn't working, just to kind of rule out the fact that there could be anything specific to the Pygame display that would be actually causing it to be broken. One thing we want to do on the PC is also probably update Blinka display.io. Show? I don't actually know the root. Oh my. 723 dev 5? Display.io is 0.10.2. Blinka is 8.5.0. 0.10.2. We're good there, but Blinka is a little older, so let's install Blinka. I don't think should really factor into this, but it's always good to be testing with the most up-to-date stuff, so. Go, 8.5.0. So now we can do stuff like run these Pygame examples, Pygame display examples. Simple test. One uses label. Oh no. Yep. We need to update platform detect also. So sometimes I will say, sometimes this gets broken by like the fact that Blinka is not actually really intended to run on laptops. Blinka display.io either. I happen to make it possible by adding this Pygame display to it, but it was never intended. So like occasionally either platform detect or Blinka display.io, one of those three things can get updated and then it can stop working on the PC. And then we got to figure out why. Or downgrade, I guess, would be the other option, but we were on 723 dev 5. Let's see, does this? We went back to that version? Oh, that version doesn't exist. It doesn't work either. That is peculiar. I must have had some super weird version of Blinka installed. It was like 723 dev 5. I wonder, does that mean like maybe I installed it from my local repo? Ah, there we are. Okay, 730 works, but 850 actually does not work right now on my laptop. This, I think, depends on your laptop because Platform Detect is trying to figure out essentially what device it's running on, and more devices are getting added all the time. And like, if it doesn't recognize it, or if it does recognize it, but it's like the wrong thing or something, then it won't let you run. Like we get that error that we saw a minute ago. So I guess, yeah, probably should try to get Blinka itself working again, huh? Instead of just testing all of this against Blinka 7.30, realistically, we probably want to be back up to 8.50 or whatever the current release was. And then we probably want to go fix it or wherever it's not working. Okay, this just doesn't matter which project. Weird. Is there a JavaScript drawing library that works like display.io? Not that works like display.io. There's Canvas for JavaScript and HTML, which is a way to draw things, but does not quite really work the same as display.io. It doesn't have groups. It doesn't have tile grids. Kind of its own thing to an extent. All right, let's get back to main. Full. And let's actually uninstall three 322.0. Let's check platform detect also. Since the error we were getting was about a certain chip, something not supported, 3.31.0. See, maybe we update that and it just starts working. It'd be kind of nice. Then we're gonna install it from my repo here instead of from pip. That way, like, I'll be able to make changes to my repo and then reinstall it, and we'll get the latest version. Well, not the latest version, but the version that I changed. Under run. Oh, okay, that is working. Okay. Hmm. Is there like version? Does this work? No. We check. I want to verify that we're actually running that version. Well, I guess here's what we can do is we could just uninstall it. Maybe I'll write one. That would be pretty sweet. I would totally be interested in JavaScript implementation of display.io, because you could use it to like help learn display.io if you don't have a microcontroller. Probably could code a translator, yeah, using Canvas and CSS selectors. Yeah, I would agree. Yeah, I think it's definitely possible. you'd still have to do some conversion to JavaScript, but you could take a look inside Pygame display for kind of the core bit of how it's basically just copying each pixel over one at a time. But you'd have to be kind of changing that over to be JavaScripty. That part would be a bit difficult. No module digital I/O. Okay, so that definitely doesn't work when we uninstall Blinka, which means I think we could be pretty confident that when we run it, we're definitely running it with that version 8.5.0. In which case, it does appear that updating platform detect did allow this to work again. So I just had the old version of that. Once we updated that, now we're back to good to go. So now we could get back to label land, which is to say .bitmap label, import big label. We could just do that way. Okay, so we do have the same thing here, no text. And if we background color, we do see the background color, just not the glyphs. Oh, that's wrong. Two point 22.3. 22.11. Okay. Now we have the latest version of displays text, and we still have no text. So we are, I think, pretty confident at this point that there is some kind of problem somewhere that is not letting this work. Always good to just double check that stuff is actually not working when you think you saw it not working. The Pygame display implementation is cool. Nice, thank you. Appreciate that. Catch up here. Highlighting text while reading is like Great Scott using highlighters on schematics. It's gonna happen. Yeah, no, I highlight the text I look at a lot for sure. Whatever I'm reading, I tend to. It gets me into trouble sometimes because like you can do this kind of like moving stuff around, which is never ever ever what I want to do. I never want to move text with that, but lots of programs allow it, and so then it's even worse if I have like just a small portion of my code and then it's just like randomly somewhere else now, because I was just trying to read. How's it going, Pamela? Appreciate you tuning in. So, okay, let's get to main and update. And usually I just start with prints. I'm a lot like Scott in the fact that I'm a print debugger. See, I gotta wrap my head back around on what goes on inside of here. So reset text. Okay, so let's go just high level right here. Let's go print inside reset text. Text is text. I do the same thing with highlighting as read. Nice. Highlighters unite. Uninstall that, and then we're gonna go install it from just pip install dot. That will install it from the repo. We'll install it from the repo. Generate the wheels. How it goes. Here we are. Doesn't know the right version, but that's okay. Okay, so we got inside reset text. Text is hello world. So reset text is getting called. It is having the proper value for text. That rules out one potential cause of this. Empty string. We know it's not an empty string because we printed it out. We saw what was in it. Oh, this is interesting. What is this doing? So it has all these things inside parentheses. It's almost like a hard-coded tuple, but then we're setting it equal to something. Huh. Okay, this is returning a tuple with a bunch of things. So that must be like, I don't know what the term in Python is. In JavaScript, though, this concept, I think, is similar concept is called spreading. Okay, so we're essentially declaring all these variables by calling this function, and it's giving us back a certain number of values, which we're storing in there, so that's okay. So the interesting thing, like our box size seems okay, because we are drawing the background color. Text hello world brings back memories of Baba is you. Nice. Yeah, I'm a big, I like hello world. I like sprinkling hello worlds in all kinds of places. Let's see here. Catch up. Problem is attempting to emulate a fast-moving GitHub repo. Examples would likely be behind unless someone dedicates a major undertaking. It's like nightmare trying to keep up with the emulator. Depends on how the emulator is created. There's a Sphinx plugin that lets you run your examples as unit tests, and it helps catch the breaking changes. Oh, interesting. Or she'd mock all display I/O, but it'd still catch API changes. Huh, I didn't know that about Sphinx. The unit testing example stuff. How many PyWheels downloaded? What is a PyWheels? I can't tell you specifically what a PyWheel is, and my understanding is it's some kind of like compiled Python file. Essentially, though, when they say PyWheels downloads, effectively that means Blinka display I/O, copies downloaded or installed typically. Like when you run pip install whatever, it is downloading a PyWheel, at least in the case of Blinka display I/O. I don't know if all pip things behave the same or if PyWheel is like one option or whatever, but that is like essentially just the number of downloads. Is the way that's my understanding at least. So I'm pretty sure our box is fine because we are getting the box with the background. Place text. So text if direction is not right to left, else reverse the text, basically. If it's right to left, then reverse the text. It should still just be text, which should still be hello world. Let's print that, and let's make sure that we at least get to here and still have the proper value. Can I just install without uninstall, or do I need to uninstall? Sure. Or maybe would I need to do upgrade? Well, it's not really going to be an upgrade either, though, if it's 0, 0. Successfully built. Successfully installed. Okay. And we'll know if it didn't work, because we won't get our new print. Didn't work, then I'll uninstall it. Okay, yeah, we get there. We got hello world. So far, we're pretty deep in there, and we're still looking okay. So our problem's got to be most likely inside place text, I suppose. Let's do one more like this to make sure we get, out of place text. Make sure maybe we're just getting stuck in there or something. Oh, text is hello world. You're not saying, sorry, I misunderstood you a bit ago. I thought you were talking about just hello world. But text is hello world, which is what we printed out. I see. Okay. After place text, so we did get after that. So place text surely must be the thing responsible for actually copying the glyphs. I just had a thought. I think I might know what the problem is. This is probably using bitmap tools. It's not, though, actually. It's not using bitmap tools. Interesting. Okay. Let's just go here. Oh, X start, Y start? Let's print those. Maybe we're like putting the glyphs outside the bounds or something? Could be. Okay, let's try it this way. I feel like we got to be pretty close. I think it's got to be something inside place text. My guess is that it's probably like perhaps a minor difference between CPython and CircuitPython. Like maybe there's something being overridden or extended. We got X0, Y11. For inside place text, we do still have our actual text. X0, Y11. That seems reasonable. I think this would be like somewhere right around here, which feels like where the H would be if it was getting drawn. Okay. Then we go left equals none, right equals X start, top equals bottom equals Y start. Top equals bottom equals Y start. That's interesting. Line spacing equals self.line spacing. Huh. Let's print all of these. Let's So I mean, basically right here, we're just going to print out everything we can and just like try to find like, eventually we're going to find a variable that has a value that doesn't make sense. I mean, that's what I'm assuming at least. So this will do a few more. It will tell us left, right, top. Oops, do bottom also. Okay. Left is none, right is 0, top is 11, bottom is 11, line spacing is 1.25, I believe is the default. We do get to every glyph inside of our for loop. So we must be having trouble actually like putting it into the bitmap. This is only for new line, else we're gonna go here. We're not seeing this get printed. I'm gonna click Linka. Need that anymore. We're not seeing this get printed, so we should be going inside here. I don't know, glyph might not like, I don't know if it has a toString that's going to give us anything useful. I don't really know what glyph font.get glyph. I don't actually know what that returns. You know what we should do is try one with custom font. It just has load font. Doesn't have a get glyph. Glyph cache. Font.io glyph. Font protocol. Get glyph. Returns a glyph. Glyph. Seems like a portion of a bitmap, maybe? We got a bunch of glyphs was not nones. We got Fontio glyph objects. They seem to be different every time. Well, they're in different memory locations every time, I guess. We don't know that they're actually different. Not sure what types of properties that would have on it. Self.blit. When debugging, print all the things. Yep, is the truth. Could those be anchor points which should have a range of 0 to 1.0? I can't say unequivocally that they couldn't be that, but I think it's unlikely that they are that, because anchor point is part of the API for label, but it's not really used internally for anything. Everything internally that I'm aware of is done with pixels, XY coordinates with pixels. Okay. We have a bitmap, we have dx, dy, height, shift x, shift y, tile index, width on each of those glyphs. So either our glyphs don't contain the actual data that represents the glyph visually, or they do contain that, but when we go to blit it into the bitmap, we fail for some reason. And I do think this is probably using bitmap tools internally, but I guess it probably has a fallback. Maybe not though. Maybe that could be our problem. Honestly, I'm surprised it's not crashing anywhere. I'm surprised what it's doing is just not showing. Glyph.dx. Whoops. MyGlyph bitmap. That's just going to be a bitmap object. I guess we we could can we get this out somehow? Can we get this and save it so that we could look inside of it and make sure it has the actual glyph? How could we do that? MyGlyph.bitmap. Glyph.bitmap. I guess we could make a property on label that just stores one of these, and then we could access that property from our code and put it on the display. I will say, speaking of PIL earlier, PIL is nice when you're doing this kind of stuff because you could just save off this bitmap by itself as an image file and just look at it. Is the font just a kind of bitmap? So I'm not 100% sure how the fonts work. My understanding is yes, pretty much they have essentially a sprite sheet inside of them that is encoded in some way, and we are like grabbing glyphs out of that sprite sheet based on their XY coordinates and their height and width. But I don't know any more details than that, and I also don't even know if that is accurate. That's just the way it works inside my mind. X1, Y1, X2, Y2, skip index. Oh, well, it went with glyph offset X. If bitmap has built-in blit function, then call it. Maybe it has this function, but it doesn't work in blanket display.io. Inside blit. Same, that's what I think about of it as well. Somehow sprite sheets with background color detection to make them transparent. Yeah, it's like sprite sheet for a game. Yeah, I think it is something pretty much like that. We have a lot of stuff printed this time. Okay. About to call blit. So X positions are moving. $456? Seems kind of large, but I'm not sure. Oh, and it's okay, bitmap did have blit. Okay, here's my guess right now is that maybe it has blit, but it doesn't work, or it's maybe just a stub or something. I think that's my next guess. Let's go look. So when we're running this, our bitmap object is coming from Blinka Display.io. So that's here. Yeah. Not doing anything. Hmm. Oh. Hold on. This is the one on the Raspberry Pi. Not actually what we want to change. So I think that that function was probably written and just pass because it's part of the display.io API, but it just isn't implemented in Blinka yet, but it should be eventually, right? We want it to be. But our issue is now that we have code that says has adder blit and then tries to call it, but then that doesn't do anything. So we already have code that will do something when it doesn't have blit. My suspicion is that that code will work. So like, here's what I'm thinking now is like, let's get to main. Let's update it. Thinking if we comment out that empty blit function, probably this just starts working. Interesting, this knows the version. I wonder why display text doesn't know the right version. Has something to do with this? It's kind of a rabbit hole tangent or whatever, but doesn't actually have pyproject.toml though. Py. But now I think this prints, yeah, this prints bitmap did not have blit, which means it uses the fallback code, which means it works because it's actually doing something instead of just passing. So we either need, is the font fixed width or variable? If you mean specifically the font that I'm using right now, I don't know. It's the one that's default with Blinka Display.io, but I don't know if it's built in. I mean, if it's monospace or not, off the top of my head. I'm pretty sure that we have support for non-monospaced one. I could be wrong, but I believe that's the case. Is that if you use like bitmap font, the library, and you load a BDF or a PCF file, I believe that file can have a non-monospace font in it, and I believe it should still work in CircuitPython. I don't know for a fact if I've tested that. I've certainly done lots of custom fonts, but I don't know off the top of my head if any of them were not monospace specifically. But to the best of my knowledge, that does work. Like, is possible. So we have a couple options here. We need this function to not exist. So commenting it out makes it not exist, which means that our display text code, this returns false. We go to here. We do our own blit, which this is basically just looping over X and Y pixels, copying pixels one at a time from one bitmap to the other. That is basically what this is doing. We either need this to not exist, or we need it to be implemented and actually have code inside of it, or we need to change display text to somehow know that it's empty. But that seems very hard, right? How could Python code know that the only thing inside of a function is pass? I don't think it can know that, could it? We almost need like a function is stubbed or something. Like we need a way to indicate that we wrote the function signature, but not the implementation yet. Therefore, the rest of the code should pretend like it doesn't exist. So I wonder though, I mean, this is basically just the code for doing the blit, right? So maybe we could just take this, put it in here. And so these things are like this. Should have used find replace. I still can use find replace, and I still should. But yet, here we are. Okay. Now that we have way fewer left, I'm just going to do it. Hopefully I didn't mess any of those up, because if we got any of those wrong, that's definitely going to break it. We have source bitmap. Bitmap. So in our case, we are inside the bitmap object. So one of our bitmaps is going to be self. Target bitmap. Target bitmap. I think the one that's just called bitmap is going to be self. It is odd though. Oh, okay, we do. Yeah, okay. I was going to say it is odd we don't use source bitmap, but we do actually. Let's see here. Why have a non-functional blit function? I cannot necessarily answer that for certain. My guess is that my guess would be that somebody went through and added it because it exists in the CircuitPython API. So they added a signature for it, but did not add the implementation yet. Either they just didn't have time, they didn't know how to make the implementation, or they just had other stuff that was more important. That's my guess, though, is that the signature was added with the intention being that ultimately we want to have an implementation for it, but we don't have an implementation yet. Because like there's other stuff like this too, right? Like this is another function, but it doesn't actually do anything. And I think kind of there's just stuff like that in Blinka. Like if there's stuff that's not implemented yet, sometimes it will have the function signature, but just not the actual body, not the implementation. So that's my guess, but I do not know. Can a sprite sheet have variable width sprites? It depends what you mean by sprite sheet. The concept of a sprite sheet, just a bitmap with a bunch of smaller sprites inside of it, certainly they could have sprites with different sizes. I will say with CircuitPython, or more generally with Display.io, so whether you're using CircuitPython or Blinka Display.io, TileGrid, the TileGrid class is one of the easiest ways to work with sprite sheets, but that is actually a limitation of the tilegrid class. The tilegrid class, every tile has to be the same size. So you can't have a sprite sheet with different size sprites if you use tilegrid. What you could use, though, is not use tilegrid for your actual sprite logic of pulling the sprites out of your sheet, but instead you could just use a bitmap object with your sprite sheet, and then you could use bitmap.blit to be cutting rectangles out of your sprite sheet, copying them to somewhere else. If you do that, then you could certainly use different size sprites. You would have to write a little bit more of that code yourself, probably, that's doing the blitting and stuff. Like tilegrid takes care of a lot of that for you, but that is a limitation of tilegrid. All the tiles have to be the same size. So, but I'm pretty sure you could just skip tilegrid and just use a bitmap with blitz. Yeah, there we go. Bitmap did have blit, and now it is actually working. So now we want to go back to normal display text. So what I'm going to do is go new branch. Commit this. Are fonts MicroPython objects and not unique to CircuitPython, like palettes and groups? I do not know the answer to that one, Seagrover. I'm not sure. Are those specific to Blitz, so a common name x1, etc. won't break anything outside? I mean, scoping should cause it to not break anything outside. I'm pretty sure. I mean, they're definitely. I mean, I wouldn't say that they are like specific to Blit. X1, Y1, X2, Y2. Those are commonly used for any kind of geometry dealing with rectangles. Truthfully, but I don't think the way they're used inside of the bitmap object should break anything. Placeholders are a good way to not to forget about the feature forever. That's true. Yeah, it's in there so that it's like, here's a commit, add typing and missing CP functions. Nice. Okay. So this looks like probably where it was added, and it was just adding, it's basically just fleshing out the APIs to try to keep the APIs similar. The same, ideally. Yeah, but it's just not implemented yet. But the good news is we did have an implementation that was already written in pure Python, and we dropped that inside the bitmap, and now that's working. So I think we are going to be good to go. Tilegrid does not like variable widths. Yeah, correct. It doesn't. It has to be all tiles same size. The tile doesn't have to be square. It could be like 20 by 10, but all the tiles do have to be the same size. So all of them would be 20 by 10. Not only does the sprite have to be the same size, they have to add up to be divisible. They have to be divisible by. Have to be divisible by the number in your grid, the number of tiles in your grid. So your grid is like, 3 by 3 tiles, then it has to divide evenly to the whole bitmap. Basically, you can't have anything left over at the end or the beginning. It's a way for tilegrid to enforce it's actually working. Well, that it's actually working with a sprite sheet that it can use. I mean, a real sprite sheet, like there are plenty of real sprite sheets that tilegrid just doesn't support, but it's a way for it to make sure that it actually is a sprite sheet that it supports, just to say that it has all the tiles that are the exact same size. Because if the tiles were different sizes, it's likely that it wouldn't divide evenly on the whole width. How's it going, Johnny? Thanks for tuning in. Okay, so now we're going to go back to main. We're going to update. We're not going to update. That's not going to do anything. Is it? Maybe we should update. I think we did earlier, though. Hopefully we did earlier. Yeah, okay. Now we're going to install main. All of those things, that's what I meant. It would be awesome if we could change tile grid one of these days to have multi different sizes. That'd be pretty sweet. But I suspect it would be kind of a lot of a change internally. Maybe it'd be worthwhile making a different object that's like a sprite sheet object that uses bitmaps more like how I was talking about with Blit, and then it needs a data file that tells it the position and size of each of the sprites. But I think there's already a couple standard formats for that, so we would pick one of the standards, hopefully. And then maybe we could have it do that. Texture Atlas, that's what some frameworks I've heard call it, Texture Atlas. I'm not sure if that's like a general term or if that's specific to the things I've worked with. It might be nice to have something like that supported in Display.io. Okay, we should be able to run this. We no longer get any printing. We took all of our prints out, but we do still get text. Everything seems to be working. I'm going to take the background color out to make sure that's not like somehow helping it work. Can't really fathom a way that would be the case, but nope. Okay, we're looking good. Okay, so verdict is we need Blit inside bitmap. Hopefully I was already up to date here on main. You have dots in commit messages? Or I mean branch names? Maybe we shouldn't push it. You can have emojis though, right? Really dot's fine, but oh well. From, add bitmap Blit, from, Adafruit main, no track. Does this have pre-commit? Yep. Failed black. But, now we succeed black. We push. Let's say implementation. Thank goodness for this thing. All right, I pushed this branch too, but that one we don't want to make PR from. say last part's not true, but we're gonna. Does this autocomplete? Wow, it does. That's nice. I didn't expect that to work. Uh-oh, we detached our head. That's not good. I think. Actually, no. There we are. Now we're good there too. Okay. Sweet. Sorry, let me catch up here. An atlas is a sprite sheet that is different sizes, sure. That's a good name for it. I've worked with texture atlases in games before. Displayed the atlas with kind of a visualizer in WinderStat. Very handy for seeing your biggest textures that might be able to be optimized more. Be nice for CP game developers. That's the only scenario I see it being useful. I mean, it could be useful for GUIs, also, graphical interfaces. You could create a sprite sheet that holds a bunch of different widget backgrounds or something. TMBG did a song about that. You know, my wife likes TMBG. Did a song about what? What did I say before? Or let me know what song it is. Definitely listen to it. She'll be happy to know that I listened to something like that. We went to see them. Went to see them. Have I been a couple of times, or have I only been once? She's definitely seen him a bunch of times. I think I've been twice. I think I went to see him twice. It's pretty fun stuff. It's not the music that I default to when I'm on my own, but it is good stuff. I do like it when I hear it. They do have songs about a lot of weird things, though. I will say that. There's like songs about numbers and Constantinople, all kinds of crazy songs. They're about like weirdly specific stuff. What? That's got to be wrong. It can't have failed that fast, can it? Okay. Okay. You folks saw the red X there, right? Everybody saw the red X. This is wrong sometimes. The colors and the icons, sometimes they get out of whack. Detached head. Oh, okay. Song is Mrs. Train. Mrs. Train. Pop that up for later. But my head falls off. I haven't seen a sprite sheet for a GUI that's large enough to be split off into an atlas. Sprite sheets by themselves are still fine for GUIs. Oh, I see what you're saying. You're saying atlas has like multiple sprite sheets that organize your clock project. Well, yeah, the clock project, its sprites are all the same size. Although I guess if we supported, so with the clock project, actually, that would be a good place, actually. If we supported different sized, I'm going to call them sprites, but really what I mean is tile grid, or if we had this sprite sheet object that supported different sized sprites, if we did have support for that, the flip clock could use less memory and file size because the sprite sheets could be smaller. Because right now there is a fair amount of empty space in some of the sprites. A quarter to a half or so of the sprites are over 50% empty space, whereas if we could change them to different size sprites, then we could just make the ones that have less stuff in them smaller. Therefore, it's a smaller file size and less stuff in RAM, which would actually be pretty sweet. Because that project, it does look cool, but those files are pretty big, honestly, for CircuitPython devices. The that Feather ESP32F2, that one is like the one that is pretty much the sweet spot because it has a lot of RAM and a pretty decent sized file system. So why did we fail here, but we passed locally? Build docs, okay. 523. Is this in conf.py or? Okay, that's easy enough. Does seem odd that it was like that. Okay, yeah, this one has EN. I don't know. Failed black, probably because I used the wrong quotes. I used, I think, single quotes instead of double quotes. Yeah. Not the wrong quotes. I think both are fine, but black decided that double quotes are what you use by default. Smart quotes are the wrong quotes, always. I wonder how they decided double quote outs on the outside. Is that like straight up just a coin flip, or is there some rationale that makes that better, I wonder? I will say I really, really, really like Python's ability to put quotes inside of quotes. I guess JavaScript does this too, but like, like if you want to use a single quote in your string, then you can just make the quotes that wrap your string be double and vice versa. So like if you want to use a double quote in your string, then you can just use single quotes to wrap your string. This is a feature of Python that I very much enjoy because I come from Java. More of my background is with Java, and you can't do that in Java. Single quotes have a different definition. If you want to use a double quote in your string, you have to escape it with a /, which you can do in Python, but it's kind of inconvenient, especially if you have a lot of JSON that is inside of a string, because it turns out JSON doesn't support single quotes, for one thing, and has a lot of quotes inside of it, generally. So then you end up with this weird JSON that has a bunch of backslashes everywhere. Or is that a /? I don't know which way the slash goes, honestly. I don't really know my / from my backslash. I know them as the one that's used for escaping things, and the other one, which pretty much isn't used for anything? Or is the other one is the one that's used for URLs, yeah, and dividing. That's pretty much how I know them. One of them is used for escaping, one of them is used for URLs and dividing. But I do not know which one's front or back. Oh my goodness, what have I done? Does that change the display? It does. What is this? Section? Stickers? Emojis? Like a... I don't know. I don't know how I opened that, or not sure where the X, surely there must have been an X button there somewhere hidden, but / for escaping, / for getting to websites. Or comments, I guess. / for comments. What's the one that's in Guns N' Roses? Oh, I might have got that wrong. I don't even know if that's /. Hopefully I didn't just wreck that joke by saying the wrong band. I don't really know bands that well. Now I'm paranoid. I think I did, didn't I? Is that actually /? Is that / GNR? Is that right? Okay. That's good. Now that I just explained the fact that I thought I got it wrong, it doesn't really change, but that would have been pretty bad if I got that wrong, I guess, right? /. Yeah, that's true. Windows has the what I will refer to as the wrong / for paths. That's true. And unfortunate, if I may be honest. It would be nice if Windows had used the same / as Linux. Because URLs use the same / as Linux. It's pretty much like retrieving files, which is pretty much like reading files from the drive, so it'd be nice if they were all the same. GNR, okay. But I didn't mess it up, although I kind of revealed the fact that I don't actually know afterwards, so maybe I didn't save myself anything. I'll say librarians. I mean, I would assume that it's pretty likely that Melissa probably would be the one to review this. Melissa is the main sort of driving force behind Blinka Display.io, so and Blinka as well, actually. So we shall see. I'll do CircuitPython librarians. I think that she's in there anyway, Melissa. So I think that should show up in her feed. But if we go a couple days or a week or something and nobody has reviewed it, then I will look Melissa in there as well. Take a look at it eventually. / is for MOD in some languages. / and / meme somewhere. Cool. All right. So that's what I was intending to do, was try to figure out why this was broken and fix it. And I would say we have done that. Not Normally I go about 2 hours. That leaves us with about 15 minutes, which is not a whole lot of time. Here's what we're gonna do. I'm gonna look at this for a little bit. I don't know how far we're gonna get into it, but I'm gonna look at this. This is a thing I saw recently from a community member, Schultronics, and I cannot resist display IO stuff, so I happened to see this the other day and made a note of it and wanted to look into it. I don't really know what all is in here yet. I don't really know much about it other than it's a graphical interface and it works on CircuitPython, but that much tells me that it's right up my alley. We will see if we can get this to do something for us here. See if we can see some of the stuff inside of it. What was it called? Display IO Universal UI. I use Windows and I use I'm called the / character solidus. Really? They have a way to let you do the /? I haven't used Windows for a while. I bailed after 7. I never did update to 10, and I got a Linux computer for my next computer after that. Solved my lower board problem, user error, had them wired up wrong, working fine now, sweet. Yeah, the LoRa stuff, there's a lot of details that go into it. I have probably made similar mistakes to you in the past of like not getting stuff set up right and then wondering why the messages weren't going through. JSON is so different to edit when URL it had to change. On Windows URL way to the other slash. JSON was so different to edit. Wired up GPIO to IRQ instead of reset. Ah, okay, yeah, so it couldn't reset the LoRa module, it was just flipping the IRQ pin. Yeah. You customize your terminal. Ah, okay. I used a thing called Sigwin, which was some kind of like third-party terminal. Interesting. Interesting. Okay, so we have like a widget class. Which it seems like, okay, and then we extend, so we have text widget. Okay, so widget is like our base class. We have text widget, we have icon widget, graphics widget. A clue. I mean, I have a clue, but it's not here on my desk with me. GUI toolbar widget. GUI.update display. We should be able to make this work. We don't need any of this because the display is built in. We do that. Already got import board. I think that should work. Oh, don't have that. And then of course I don't have GUI here either yet, so let me copy that over. From GUI. Oh, GUI is here, I see. We will need the library too, though, right? We don't have the library yet. Ultimate PowerShell prompt with oh my posh. Oh my posh. WSL is pretty nice. Uninstalled it, chasing down a bug just to find out WSL isn't even remotely close to causing the bug, but I was desperate. Had a circuit that would reset every time I changed one pin to 0. Turns out there was a solder bridge to the reset. Cygwin gives you the bin utils and bash shell. Yeah, I remembered that. It gave me basically the basic bash stuff, which would then let you use some scripts that were made for Linux, as long as they didn't use anything too crazy. Shultronics edition is pretty great, just going on what I've seen in your streams. Yeah, I'm pretty stoked. I think we'll probably spend another stream at some point. I don't know if it'll be tomorrow or maybe next week, but I think at some point we'll spend a stream diving a little further into this and playing with it. I'll get my Clue out and we can run it on Clue, desktop, and Raspberry Pi. Just kind of see the different stuff. Because from what I understand, this is supposed to be a UI library that is focused on being cross-supporting. And I'm always a sucker for a UI library, for sure. We might be out of space. That should be enough, probably, hopefully. Happens to the best of us. Yeah, hardware is an interesting thing. Like, my whole background is more with software than hardware, and the idea that like your software breaks because a pin is touching another pin, like that adds a whole new layer of troubleshooting. Okay, display shapes. Being able to write programs that affect like physical stuff in the real world, though, is really what draws me to CircuitPython too. So while it certainly does make troubleshooting a lot different, nice. It's also kind of like the main draw, right? Like as a person coming from programming, the fact that I can now write a program that interacts with the physical world, that is just like the coolest thing to me. Is really the thing that hooked me into CircuitPython. This one basically just updates the time. Now, one thing I don't know, is there anything besides the label there? Because it calls this, whoa, whoops, what are we doing? We don't want to do that. Stop, what are we doing? Do that. It calls it a toolbar. That set value, toolbar widget, is a text widget, okay. Interesting. Okay, so we got the basics running. We got kind of the simple test running with our label that is updating over time. And speaking of time, we're pretty much at time for this program. So yeah, I will dig into this. Again, this was Schultronics library. If anybody is interested, it is here on GitHub. I'll drop the link into the Discord, Schultronics Display.io Universal UI. I will probably dive deeper into this in a future stream, but I'm glad we got to this point at least, like got it displaying and updating. That seems like a decent chunk of the battle. So we are there. We'll look at that in a future stream. Thank you everybody for watching. Thanks for everybody who is chatting along and offering suggestions and asking questions and just hanging out with us in the chats on Discord and YouTube. Thanks to you folks. Like, this is kind of one of the best parts of my week, certainly, that I look forward to all week. And a lot of it is just because I get to hang out with you folks who come and watch along and hang out in the chat. So thank you for that. I appreciate all of you. Appreciate everybody who's watching, even if you're not in the chat as well. That's awesome too. I'll be back tomorrow at 10 a.m. Central Time for my next stream. I don't know exactly what I'll work on. Maybe it'll be this, maybe it'll be something else. Depends on what we're feeling in the morning. But that's when I'll be back next, 10 a.m. Central Time tomorrow. That one will be on my own channel rather than the Adafruit channel, and I'll drop links in the Discord when I am about to get started. So if you can just, if you're interested in watching along tomorrow, you can head to the same Discord we're in now, the live broadcast chat, and I'll put the links in there when I'm getting ready to start up the stream. So yes, thank you again to everybody for watching. Thank you again to Adafruit for sponsoring the folks who work on CircuitPython. Thank you to all the members of the CircuitPython community for just being awesome. And like, honestly, it's just one of the coolest like communities to be a part of because pretty much everybody's cool. So thank you everybody for being involved and being cool. That's going to be it for now. I hope everybody has a good night and a good Friday, a good weekend, all that stuff. Hang out, do some fun stuff, and